Hi there, this is the first video of Stats Chapter 1, which is called Data Collection. So this chapter sort of roughly comes under the idea of experimental data. So if I go back to this one here. So chapter number one, data collection, as I said. We're talking about kind of collecting real world data. We're going to talk about what a sample is, why we might want one, how we would collect it, and so on. And then we're going to sort of like use the data to calculate things. That's kind of where we are at the start of our journey. So we're going to start by talking about what a population is versus what a sample is. Then we've got our random sampling methods, our non-random sampling methods, types of data. This is going to be a very quick one. And we're going to start to look at what is called the large data set and what you need to know with this. So a couple of terms to start with. The population, we might think of the population as being the whole set of items. The whole set of items, or everybody who could be asked, or everybody who could be tested, everything that could be tested in some sort of investigation. A sample is just going to be a subset of that. So subset is the key word. We're saying a subset of the whole population. So it's part of it. And the key idea is this is meant to tell us something. It's meant to give us some insights for the whole population. So a sample should really be representative of the wider population. Now, there's two terms that sometimes come up with this. First one for you to know is a sampling unit. So a sampling unit means like a potential person or a potential thing that could be part of the sample. Okay, so we could say each individual thing. Again, this kind of depends on context, and context is really important for stats. So each individual thing in the population that could be sampled. Okay, so I know there's a bit there, but for example, if we were talking about like a school context, it might be a pupil might be a sampling unit because we might say that any of those pupils could be asked. When we put the sampling units all together, we get a sampling frame. A sampling frame, the easiest way for you to think about this is all of the sampling units together, typically sort of like in a list or something where we can sort of see who they would be all at once. So maybe like a register of everybody at the school in the example that we just come up with. Okay, best to think about the sampling unit first to help you think about what a sampling frame is. So a few definitions at the start with this first chapter. So one question sort of based off recent years exam. I've got some data here. This is data from 1987 from Heathrow. It's the first 15 days of June. And what's it about? It's about the daily mean temperature. So why have I picked this? Well, you're going to see later on. This is one such time and location in the large data set. So what would be a potential sample from this data? So for now, I want you just to pretend that this is sort of the whole population. What would be a sample of this? Well, we could say something like, we could say the daily mean temperature. And yes, we do need to be this specific. So we could say the daily mean temperature in Heathrow in 1987. Okay. And then if it's a sample, the idea is it's a subset. So we just want a smaller amount for, should we just say for the 1st to the 5th of June. Or I could say every other day, like the 1st, the 3rd, the 5th, something like that. Okay, this is kind of what we're looking for. So key thing here is you really have to be sort of this specific with these terms here. Okay, and then it needs to be clear that it is in fact a sample. Let's think of it the other way around. What could be the population that it's a sample from? Well, it might be from all the locations in the large data set. And at the moment, you don't know what these are, and that's okay. but you could say you could say something like multiple. You could say multiple years in Heathrow. You could say multiple locations. The idea is we're trying to communicate that this is a smaller amount. Well, for this question here, we're trying to communicate this is a smaller amount than the whole thing. So have a go one more time here and just sort of think about what you might say. So things have changed a little bit. This is another example here just from the large data set. What would you say could be a sample, and what could this be a population from based on your knowledge at this point? Well, a sample, again, anything that means not all of the days. So 2015 is the other year in the large data set. Leeming is one of the, I think it's 7 locations off the top of my head. Might be 8. And what else? And it's May, okay? So the first 15 days of May, if you are interested to know. And this is a very useful fact that will come up later. The large data set covers May to October, so that's why we just picked this part here. If it's May to October, you might say that this is sort of like relatively wet. You might say these are some wetter days. Those of you as well who are quite sort of sharp on reading that data may have noticed trace. Trace, given by TR, means a very, very small amount. It's not 0, but it's a very small amount. So the advice here is to treat this as some sort of number between 0 and 0.05. It depends where you read this. These things are all accepted. Changing it to this number, I've often seen as well, change it to 0.025. Okay, so that's how you could interpret that. But the point on this is we would just say, you know, the daily total rainfall in 2015 for Leeming for just the odd days from the 1st of May to the 15th, something like that. What could it be? A population? So it could be other days of the year. It could be other years. It could be other locations. Let's get on now to populations and samples, because we don't necessarily always need to take a sample. We can look at the whole population. If we do that, this is called a census, okay? So looking at the whole population is called a census. So famously, a census in the UK might make you think of a big survey that's done every 10 years where lots of information is collected and really lots of effort is made to try and make sure that the whole population is represented. So what's really good about this is it should be completely accurate. If you want to know what's going on, you will know what's going on because you've got all the information. The disadvantage, okay, and use time consuming and expensive. You're going to use these a lot in this chapter, these points here. So talking to everyone, they often like knock on the doors and come back and so on. They really do try very hard. And people, I'm not sure if they volunteer or they're actually paid. I believe they're paid to try and get this information. We also have the problem that, think about, say, batteries, testing batteries for a moment. Well, if we test every battery in the factory, we don't have any more batteries. So this idea is called destruction. It just means you use them up, you don't have them anymore. It also gives us massive amounts of data, which we may not want to deal with. So a sample then. A sample, well, the first thing is it's sort of, a case of these ones being similar, really. It's cheaper, it's quicker, and there's a far lot less data. The problem is we might be sacrificing the accuracy of it. So the data might not be accurate if we don't have a big enough sample size, for example. Another problem as well is we may have groups, small subgroups, or sometimes strata, they're called, these groups. And if our sample is not done mindfully enough, we might ignore the strata, and we don't want to do that. We've got a quick question here. It says, a supermarket wants to test the delivery of avocados for ripeness by cutting them in half. Suggest a reason why they shouldn't test them all. Well, we wouldn't have any avocados left if we do that. So destroy is the word that comes up here again. The supermarket tests a sample of 5 and finds that 4 of them are ripe, so 4/5. They estimate that 80% in the delivery are ripe. Suggest one way the supermarket could improve their estimate. Well, 5 is a very, very small amount. So we want to talk about increasing the number of items that are part of the sample to come up with a better estimate or more accurate estimate. So a larger sample size is what we would say. We're going to go on to, in the next part then, talking about the types of sampling now that we know that this can be useful. But we're going to stop it there for the video 1A.